Good afternoon, everyone. My name is Isada Nitzel, and I'd like to welcome you back to another Tech Talk in our series sponsored by Pressable. Today, we have the pleasure of welcoming Sabrina Ira to give us a brief talk on WebAssembly. So without further ado, I'd like to pass it on over to you, Sabrina.
Thank you, Isara. Good morning, everyone. My name is Sabrina Ira, and I'd like to thank Pressable for sponsoring my Tech Talk today. So let's begin. JavaScript. It may be the one you want, but it isn't always the one you need. JavaScript has been the backbone of web development for decades. It's versatile, it's accessible, and it's everywhere. But the hard truth of it all is that it has its limits to what you want your web applications to achieve. Whether you want it to build a game with higher graphics, run complex simulations, or process high-resolution images or videos, all of those things with a browser, JavaScript can only do so much. In this day and age, we expect many web applications to be fast, responsive, and powerful for many users. Whether it's creating media content, 3D rendering, or data visualizations, JavaScript alone falls short. So there has to be another way. And there is another way. No, we're not trying to replace JavaScript, but rather complement it with something stronger that can handle running advanced web apps better without these limitations. No offense to JavaScript, though. Enter WebAssembly. For today's Tech Talk, I'll be walking you through what WebAssembly is, what it does, and why it matters to the web. We'll be covering a high-level overview of WebAssembly, so by the end of this presentation, hopefully you'll get a solid grasp of what it's all about. So what is WebAssembly? WebAssembly, or WASM for short, is a low-level binary instruction format for a stack-based virtual machine. To break it down, it's not like a completely different language. It's not really even a language at all. Rather, it is designed as a portable compilation target for other programming languages, enabling deployment on the web for client and server applications. Additionally, it is meant to run alongside JavaScript, so it's not a total replacement. WebAssembly just wants to work together with JavaScript. So whether you're building games, virtual and augmented reality, multimedia tools, or data-intensive applications, WebAssembly opens up a world of possibilities by bringing near-native performance to the browser. And by near-native performance, meaning your computer hardware executing the code. So let's look into how it works. So WebAssembly, the code of WebAssembly can be expressed in two ways: binary format or in readable text. So what you see here is a binary format of a WebAssembly module. To recap, the web binary is a machine code that are basically ones and zeros. So whenever you hear the word WebAssembly the next time around, just remember this is basically what WebAssembly is. But it's pretty obvious that we humans don't usually read or write this off frequently. Well, I'll explain why in a while, but first you want to understand how this will benefit the browser performance. So browsers can decode and compile WebAssembly files much more quickly than JavaScript because it avoids costly parsing and optimization. So while they're stored and executed in binary format, like in this image, you already know that it can be quite hard to read. It can even be more difficult when you need to debug some code around there. So there's no way developers can write this from scratch. So instead, they would have to code in other programming languages and compile them into WebAssembly files. Such languages include C, C++, Rust, Go, and possibly more. So if you're like a C or C++ developer, you would use Ebscript10, which is a compiler that converts the code into a WebAssembly module. Or if you're using Rust, you would have to use WasmPack. Since the binary format is too hard to read and understand, fortunately, there is a readable text format to read the WebAssembly modules. So what you see here is a WebAssembly text format, or WAT for short. This is the same example from the previous slide. So instead of raw binary, the WASM text format uses X expression syntax, similar to Lisp-like structures and assembly language, if you're already familiar with those. But with this syntax, it allows human-readable language from binary text, and this will help for easier debugging and modifying modules manually. So why was WebAssembly created? WebAssembly was created by several browser vendors such as Mozilla, Microsoft, Google, and Apple, with the main goal of achieving near-native speed when running applications on the browser. It is designed to be an effective compilation target for source languages like C and Rust. Then, it needs JavaScript to load by acting as a loader in order to let WebAssembly to run within the browser. So with WebAssembly, it provides a way to run code written in multiple languages on the web, with client apps running on the web that couldn't have been done before. So here are some key features. Performance, as mentioned earlier, it runs at a near native speed. It can be decoded and start executing before JavaScript code can even be parsed. Additionally, WebAssembly modules are designed to be smaller in size compared to JavaScript code, resulting in faster loading times. Another key feature, portability. Since it is not tied to any specific operating system by running in a standardized virtual machine, it can be executed seamlessly across different operating systems and browser environments. And with its compact binary format, the file size is very minimal. Then you have security. It runs in an isolated sandbox environment, which prevents it from accessing system resources, preventing potential vulnerabilities and other malicious code. So let's look into some real-world use cases where companies have utilized WebAssembly. High-performance games and 3D rendering. This is the most recognized use case for integrating WebAssembly. At present, the standard gaming performance and visuals are pretty much high. Unity, a popular game development engine, utilized WebAssembly to export games directly to the web via WebGL. This will allow game developers to build games using Unity, then export them as WebAssembly modules and run them within the web browser. Another real-world use case is data visualization and real-time analytics. Visualizing large data sets can be resource-intensive. With WebAssembly, it can process large data sets in real time. Plotly here, specifically their open-source graphic library, is a popular data visualization library that integrated WebAssembly to exchange the performance of its rendering engine, providing smooth and interactive data visualizations in the browser. And then finally, another real-world use case are blockchains and smart contracts. With WebAssembly's sandbox environment, it ensures that the smart contracts are executed safely, benefiting handling decentralized finance operations, governance protocols, and cross-chain interoperability. Polkadot here, a next-generation blockchain network, uses WebAssembly as the execution environment for its smart contracts, enabling faster and more efficient transaction processing. On the other hand, Ethereum, as of this time, has proposed a redesign of its own smart contract execution layer by using a deterministic subset of WebAssembly, officially naming it Ethereum WebAssembly, or EWASM for short. So those are all the real-world use cases. So while there are some great benefits to using WebAssembly, such innovation always has its own challenges. So here are some of them I want to highlight. Since WebAssembly is a low-level binary format, it can make debugging harder, which is why you would have to convert a WebAssembly file into a readable text, as explained earlier in the beginning. While modern browsers such as Chrome, Edge, Firefox, and Safari support WebAssembly, some older browsers may not have that same compatibility. This would require developers to come up with fallback solutions or maintain JavaScript alternatives to maintain accessibility across all platforms. And then lastly, WebAssembly is quite a complex tool, which makes it a steep learning curve for JavaScript developers, given that WebAssembly contains low-level concepts that aren't introduced to JavaScript. So here are some key takeaways. Real-world impact. It's already powering applications in gaming, data visualizations, and blockchains. Another key takeaway is language flexibility. You can write WebAssembly code in languages like C, C++, Rust, Go, so much more, just by compiling them into WebAssembly files and then run them within the browser. Another key takeaway is that it is not replacing JavaScript. WebAssembly works alongside JavaScript, allowing developers to use the right tool for the job. So JavaScript can still handle the general purpose task and running the application, while WebAssembly is suitable for performance critical parts of the application. And finally, WebAssembly is portable, secure, and efficient. It helps run advanced build web applications seamlessly on any modern browser and operating system, operating within a virtual sandbox environment to prevent potential vulnerabilities and malicious code execution. And it's optimized for performance by using a compact binary format for faster loading and near-native execution speeds. So if you're already interested in checking more about WebAssembly, I definitely recommend these sources to get started with. You can find them all in here. Oh, but what about JavaScript? So if we want to utilize WebAssembly, do we need to learn those system programming languages? Not really. You don't necessarily need to learn those languages to use WebAssembly. So if you're a JavaScript developer and you don't have time to learn those kinds of languages, no worries, because you've got AssemblyScript. So it is a TypeScript-like language designed specifically for this, for WebAssembly. So it will allow you to write WebAssembly code using a syntax that's very familiar for JavaScript and TypeScript developers. So unlike the system programming languages where they need a compiler to convert into WebAssembly binary format, AssemblyScript compiles it directly. So if you're already fluent with JavaScript or TypeScript, this means you have the opportunity to try and incorporate WebAssembly into your projects if you want to. You can definitely check out the website located in the bottom right corner to learn more about AssemblyScript. Anyway, here are the rest of the references that helped provide many of the valuable insights of WebAssembly. At this point, you finally have a basic grasp of it. Hopefully, the sources I've shared with you all will further deepen your understanding of it should you find yourself wanting to seek more about this technology. It's worth learning since it will help expand your knowledge of web development and open up new possibilities. And here's where you can reach me. So once again, I'd like to thank Pressable for sponsoring this Tech Talk, and I'll open the floor for any questions you may have regarding WebAssembly. Otherwise, I'll just popcorn it back to Isada.
Well, if there are no questions, I'd like to thank you, Sabrina, so much for that informative talk. And thank you, everyone, for coming out today. And we will see you at the next talk.